First of all, a small description of what's on the front of the control panel. To the very left is a key switch. Below the key switch is the motor control switch. You switch it left for the CNC mode and to the right for the manual mode. To the right of the motor control switch is a potentiometer. This is to set the spindle speed manually. The calibrations of the spindle speed are around the outside of the dial, so that you can set to whatever speed you wish, up to a maximum of 2000 RPM. Above the motor speed control pot is an emergency stop button. This is a lock-off type of button, so that if you press it, it will lock in. So then it will need rotating as shown clockwise to release it to reinstate the power supply. Only use that on emergency occasions, otherwise you'll lose the program that's running. To the right of that is a 4-position switch. This allows you to select inch or millimeter programs, and also to select either vertical mode or horizontal mode for the spindle. So you've got 4 positions there that you can set it in. At the moment it's set to millimeters mode in vertical. To the right of that switch you have a small cassette tape. This is for recording programs. And it is a Philips LDB 4401, and it's 2-sided. To the right of that we come to the main input pads. The green buttons are so that when you're in manual mode you can move the carriage, the table, in the X direction, to the right or to the left, and to the back or to the front. And this is for the vertical column move, so you can bring the column down or you can raise the column up. The speed at which these work in is controlled by the potentiometer at the top, and that is marked in graduations from 5 millimeters per minute up to 400 millimeters per minute. So whatever you've got that set at, when you use these buttons it will travel at that speed. If you want it to go at high speed, which the maximum speed is 400 millimeters per minute, the blue button, if you hold the blue button in when you use these manual access buttons, it will travel at 400 millimeters per minute. That's a maximum travel. To the right of that you have the numeric keypad. You also have there a minus sign, a negative sign, which you have to use in some movements obviously. Then you have an input button, delete button, reverse button and forward button. HC is the button that changes between manual mode and CNC mode. When it's in manual mode you'll see the light here, the green LED will be illuminated. I'll switch it on now. So the green light is on, which means that we can move in a manual mode. For CNC you press it and the light above the HC button illuminates to indicate that you're in a you're in a CNC mode. You'll also see that the line number that the program starts in is 00. It doesn't start at line 1, which is a bit confusing. It starts at line 00 in the program. When you first switch the machine on, it will be starting up in an incremental mode. If you want it to be in absolute mode, then you have to enter either a G90 into the column, G column, or you can use the G92 and set the axes by entering the position at which the carriages are set at. So you set the X position, Y position and the Z positions. This is a short program that I'm going to show you how to enter a short program to carry out a G72 pocket operation. At the moment we've got the machine set up in CNC mode. It's in incremental mode, in metric millimeters and in the vertical format. On the screen we've got the number of the line, got a G column, X column, Y column, Z column, or Z as you Americans call it, and an F for the feed rate column. So the first line of entry is going to be the tool that we're going to use, and this is going to be a 3mm cutter, 2-flute cutter. So you press input to move the cursor into the G column, and the tool change code is M06. Input, and it's got a D there which is asking, which you can think would be diameter, but actually you enter the radius, which is 150. You note that I haven't put no decimal point into the 1.50. You don't enter decimal points in the Emco F1 milling machine programming or into the Compact 5 CNC program. It's just the tenths and hundredths of a millimetre. So 00 is the tenth and the hundredth. And the Y column, it's showing as an S, so it wants you to enter the speed of the spindle. It's a small cutter, so we'll use the maximum possible, which is 2000. Now the Z column is for you to set the height offset of the tool that you're using. Well, as this program is only using this one tool, that will be set up at a 00 position. So we enter 00 in the Z column. Press input, and its tool number, we'll call this tool there 01. Press input, and you move then to the next line. So the next line we'll start the spindle, and the code for a spindle start is M03. So we press input, M03 input, and it goes down onto the next line. Now we want now to move the tool from its present position, which is rubbing the back of the block and the left hand side of the block. We now want to bring that through to the position to cut the pocket. Well, in this instance we need to move the tool 9 millimeters to the right as we view the machine, and 14 millimeters towards us, which is a negative Y movement, and the X travel will be a positive X movement. So you press input, it can move, because the tool is 1mm clear of the top surface of the work, it can be a rapid movement. It's not cutting any material, so we want the tool to arrive at its destination as quickly as possible. So we'll use G72, press input. Now X, we know that it wants to go 9mm, that's 900, press input, and the Y we know wants to go 1400, and then negative, so you press the negative sign, which is in the bottom left hand of the numeric keypad. Press input. Now you'll see there that after I pressed the input for the 14, the cursor went back to the next line. That's because with the F1 you can only program 2 of the 3 axes. You can program any of the 2, the X and Y, X and Z, Y and Z, in whichever fashion you require, but you can only program 2 movements of the 3 axes simultaneously. So now we've arrived at the point where we want the pocket to start. So I think it's a good idea here to enter, we'll input and we'll enter an M00, press input. And M00 means that the program will stop at that line. Before carrying on you'd have to press the start button, but that will allow you time to confirm that the tool is in exactly the correct position that you want the pocket. You can use this for the first run or two to make sure it's doing exactly what you want, but then you can delete the M00 after a few operations, because you know that the program is doing as you wish. So now the next line, 04, what we're going to do there is going to enter a drilling operation to take the tool into the material. And what we're going to use is we're going to use a G73, which is a peck drilling operation, and I'll explain the reason for that as when we get to the end. And at the moment the tool is 1mm clear of the work and we want it to go into the workpiece 1mm, so we need to have a minus, need to have a 2mm minus in there. And the feed rate that we're going to send the tool into the work at, we'll say it'll go in at 30mm per minute, which is quite slow, but the reason for that is that if you're not using a backstop on your tool, when you're plunge cutting you can sometimes push the tool back through the collet. So anyhow, now we've got to the point where we've drilled a hole to the depth that we want the pocket to be, so that we can now enter the pocket command, which is press input to get it into the G column, and the pocket command is G72 input. Now we want the pocket to be 12mm wide, so enter the 12. We know that we want the cut to go to the right as we view the machine, so that will be correct. Press input. We want it to be 12mm in depth, and we know that we're starting at the point closest to the operator, so we'll leave that as a positive. And we want the pocket to be 1mm depth of cut, so we need to make that -2, because the tool, remember, is 1mm clear of the work surface, so that's 2 negative. And the feed rate for the cut, it's a 3mm cutter at 2000 RPM, and we're cutting it into aluminium, so we can safely go in at 100mm per minute. So there, that's your command for the pocket mill. When the milling is complete of the pocket, the tool should raise back to the point at which it started, which will be 1 mm clear of the surface. But to ensure that it does, we need to enter another command, another M00. But before that, we'll stop the spindle, so that when the pocket is cut, if you're working on another machine or doing some assembly on your bench, you'll hear that the spindle is stopped. Will give you an audio indication that the pocket is complete, and it wants you to check that the tool is clear of the pocket before the next operation. So that's why we've stopped. We've done the pocket, stopped the spindle, and then it's now waiting for you to press the start button again to make sure that the tool is clear, and then it can go back. The tool can go back to the datum point, which we'll enter now. And the tool will be clear, it's in free air, so it can go back to the datum point as quickly as possible. So we press the arrow to get, right hand arrow to get it into the G column. It's going to be a 00 code. Now we know that from the point it's finished at, it came 900, so we need to put in there a negative 900. So it's a 900 negative minus. And the same with the 1400. We need to be 1400 in there positive. So those two lines will be the same dimensions, but they'll be opposites. That's positive, that's negative. That's positive and that's negative. There's one to bring it out to the job from the datum, and one to take it back from the job to the datum. And that's the last line in the program, except we now need to tell the computer that it's finished the program, and that's an M30. Press input. So we've now got the program entered. We can scroll back to that one at a time with the reverse button, or you can press it, hold reverse, and then press the input, and that will take you back in one leap. We'll just check we've got everything it should be. We've got a 3mm cutter. It's going to go at 2000 RPM. There's no tool offset to set. It's tool number 1. We've started the spindle. The tool is going to travel 900 in the X, which will take the tool to the right. It's going to go 1400 negative in the Y, which puts the table away from you. The tool comes towards you, if you like. And it's going to reach that point, and the program is going to halt, so that you can check you're in the actually right position. So after that you press input again, and it'll do the drilling cycle to drill the hole, pre-drill the hole. After that it will do the pocket milling. It will come out from the pocket and the spindle will stop, give you an audio warning that the spindle has stopped, and it will sit there waiting for you to check that the tool is clear of the work, so it can go back to the datum before you press the start button again for this MOO, from this MOO command. And then the tool will go back to the datum in that line, and then the program finishes. That's all pretty clear. The next line will show you the next video will show you this program in operation. I hope you've learnt something from that, or it's helpful for you. Thanks for watching. Bye for now. Right, we're all set now to run the program through. I've set the motor switch to CNC, adjusted the RPM to 2000. We're in line 00, which is the start of the program. So what we need to do now is press the start button, and that takes us into the line which stops at the speed column, to make sure that you can check that you set the speed to the spindle as you've got it in the program, which is in this case is 2000. Press the start again and the spindle starts, and the tool moves over to where we want the start of the pocket. Because it's in the correct position, we'll make the first cut. Press the start button, now you can see that it's finished the cut and the spindle has stopped, and we can see that the tool has moved clear from the pocket. So we now need to press the start button again for the program to continue, which now takes the tool back to the datum point, and that's the end of the program. That's that one finished. I'll run it through again just so you can be sure, but I'll leave the settings as they are in depth, so it won't be cutting, but it'll be simulating the cut. And that's the hole, waiting for us to confirm that it's in the correct position before we press the start to continue the operation. It steps over the percentage step over the tool. I can't exactly remember, but it's less than the tool width. That's the reason you have to enter the diameter of the tool in. Program complete. I'll post the details of the program, the code of the program, on the IO group Yahoo F1 Mill. That's the Emco F1 Mill. It's dedicated to F1 milling machines. There's a link below the video which will take you to the join page if you're not already a member. There's a lot of folders in the file there with useful information, service manuals, programming manuals. You can learn all you need to know about the F1 if you visit the group and look in the files section. Electrical schematics to help you through any fault finding you may want to do or have to do. It gives you all details of all components, fuses, sizes, etc., etc. Well worth a visit. Thanks for watching. I hope the video helps you. Bye for now.